Hello viewers, I Neela welcome you to the chapter of break-even point. In this unit, we'll study the meaning of break-even point. We'll study the linear analysis methods of break-even point such as graphic and algebraic method. We shall discuss analysis of break-even point in case of non-linear, total revenue and cost curves, and how to change break-even output, operating leverage and limitations of break-even point. Break-even analysis is also sometimes called profit contribution analysis. Theory of cost has a significant application in the decision making of the firm regarding the level of output at which it will attain no profit, no loss position. Break-even analysis is applied to determine the quantity of output sold at which the firm will realize its target level of profits. Break-even analysis can be made by assuming firstly linear cost output and revenue output relationships, and secondly by assuming non-linear cost and revenue functions. Likewise, break-even analysis can be either made through graphical method or algebraic method. In our analysis, we'll explain break-even analysis through both of these methods. Break-even analysis is based on revenue functions and cost functions. Now, image 1.1, that is of break-even level of output and sales. Image 1.1 graphically shows a typical linear break-even analysis chart. When price of the product remains constant as the firm expands its production and sales, the total revenue will be linearly related to output. Therefore, the total revenue function TR in image 1.1 represents the total revenue that the firm will earn at each level of output, assuming that the price P of the production for the firm remains constant. Similarly, the total cost function of TC is a straight line starting from point F on the y-axis and thus represents the linear relationship between total cost and output. It may be noted that in our analysis of cost function, we have explained that average variable cost falls over a range of output in the beginning and then begin to rise. However, the managers of business firms who use the break-even analysis are interested in relevant middle ranges of output without considering the extremes of low and very high ranges of output at which average variable cost falls or rises. Hence, linear cost function represented by the straight line curve is generally used in break-even analysis. TFC is the total fixed cost line. With a given fixed cost line, TFC represents a total variable cost. As will be seen from image 1.1, the vertical distance between the TC and TFC curves representing the total variable cost increases as the quantity of output produced and sold increases. But TC line is linear starting from point F, which shows that the average variable cost is constant. It will be further seen that the slope of the total revenue curve which indicates the price in which additional units of the good are sold, is greater than the slope of the total cost curve, which indicates the additional variable cost incurred per unit of output by the firm. This means the price which the firm receives for every unit of the good sold exceeds the additional cost incurred per unit of the output on labor, raw materials, and other variable factors. But the total profit loss positions depends on total revenue on the one hand and total cost, that is the variable cost plus fixed cost, on the other. It will be seen from image 1.1 that up to the quantity QB of the commodity produced and sold, total cost exceeds total revenue, indicating that the firm will suffer losses if it produces and sells less than QB quantity of the commodity. At the output QB produced and sold, the total revenue received equals to the total cost TR equals to TC, and therefore at this output level the firm neither makes profits nor incur losses. Similarly, at QB quantity of output produced and sold, the firm just breaks even. Therefore, output level QB or intersection point E at which the firm neither makes profits nor suffer losses is called a break-even point. Break-even level of output shows the minimum level of output required to be sold if the firm will just be in no profit, no loss position. If the firm's estimate of the demand for its product falls short of this break-even level, it would not produce the product. The firm will undertake the production of a commodity if it estimates that it will be able to sell the quantity of output equal to or greater than the break-even point. Further, the break-even analysis is also useful for determining the level of output necessary to make a certain target amount of profits. Suppose if the firm sets a target amount of profit for a period equal to 20 lakhs, which is supposed to be equal to ET in the image 1.2, then the level of output required to be produced and sold to obtain the given target amount of profit exceeds the break-even level. It will be seen from the image 1.2 that to realize target amount of profit pi or ET, the level of output necessary to be produced and sold increases to QT. In our above analysis of break-even point, we have assumed that both cost output and revenue output relationships are linear. However, in the market forms of monopoly and imperfect competition, such a monopolistic competition and oligopoly revenue output relationship is not linear. In these market forms, total revenue curve increases at a diminishing rate. On the other hand, short-run total cost curve generally first rises at a diminishing rate and then it starts rising at an increasing rate. We will now explain the break-even point of a firm with nonlinear cost output and revenue output relationships. This is illustrated in image 1.3, where TR represents a total revenue curve. This total revenue curve is increasing at a diminishing rate. This is because for a firm working under monopoly or imperfect competition, price of its product fall as it sells more and marginal revenue is less than price. However, it will be seen that the total cost curve TC starts from a point F which lies above the origin. It means that OF is the fixed cost which the firm has to incur even if it stops production in the short run. It will be seen that in short run cost curve, TC initially increases at a decreasing rate and then after a point it increases at an increasing rate. This implies that average total cost curve is roughly of U shape. Total profits can be measured as a vertical distance between the TR and TC curves. It will be observed from image 1.3 that up to level of OQB, TC curve lies above TR curve, showing that as a firm raises its output in the initial stages, total cost is greater than total revenue and the firm is incurring losses. When it produces OQB level of output, total revenue just equals total cost, and the firm is therefore neither making profits nor losses. That is, the firm is only breaking even at output level OQB. Thus, the point B, or output level OQB, the total revenue becomes larger than total cost and profits begins to occur to the firm. It will be noticed from the figure that the profits are increasing as the firm increases production to output OQM, since the distance between the total revenue curve TR and the total cost curve TC is widening. At OQM level of output, the distance between the TR curve and TC curve is the largest and therefore profits will be maximum. If the firm expands output beyond QM, the gap between TR and TC curves goes on narrowing down and therefore the total profit will be declining. It is therefore clear that at QM level of output, where total revenue exceeds total cost by the largest amount, firm's profit are maximum. It will be observed from image 1.3 that at output level QU, total revenue is again equal to total cost. This point K is again a break-even point, usually called upper break-even point. It may however be noted that this upper break-even point K, or output level QU, is not of much relevance as it lies beyond firm's profit maximizing level and may actually lie beyond firm's capacity to produce. It is the first break-even point B, or output level QB, which is highly significant as a firm will not plan to produce if it cannot sell output equal to at least QB, at which total revenue just covers total cost of production, so that its economic profits are zero. Although graphic method of break-even analysis is useful way of illustrating cost output, revenue output and profit output relationships, break-even analysis through algebraic model is of great help in decision-making problems by a firm. Let capital B be the price per unit of commodity sold, capital Q be the quantity produced and sold, TFC equals to total fixed cost, AVC be equal to average variable cost per unit of output, and pi is a profit. Recall that profit pi is the difference between the total revenue TR and the cost TC. To write in symbolic terms, we have pi equals to TR minus TC. Total revenue TR is equal to the price P per unit of the commodity times the quantity of output sold. Therefore, TR is equal to P times Q. Let's make this equation 1. On the other hand, total cost is the sum of the total variable cost TVC and total fixed cost TFC. Total variable cost TVC is a variable cost per unit multiplied by the output produced and sold. So, TVC is equal to AVC times Q. Therefore, TC is equal to TVC plus TFC. So, that implies TC is equal to AVC times Q plus TFC. Make this equation number 2. As explained above, break-even quantity of output produced and sold occurs at the level at which total revenue TR equals to total cost TC. Let QB indicate the break-even quantity. From first and the second equation above, at the break-even quantity QB, we have TR equals to TC. That implies P times QB is equal to TFC plus AVC times QB. So P times QB minus AVC times QB equals to TFC. So that implies that P minus AVC times QB equals to TFC. So that implies QB is equal to TFC upon P minus AVC. So this is equation number 3. Now from equation 3, it follows that the break-even quantity of the output produced and sold is determined by the total fixed cost, that is TFC, price of output P, and the variable cost per unit of output AVC. Now change in any of these variables will cause a change in the break-even quantity. The denominator in the equation 3, that is P minus AVC, is a profit contribution per unit, and the numerator TFC is a total fixed cost. Break-even depends on the following 3 factors. First, price per unit of output. Second, variable cost per unit. Third, fixed cost on capital and equipment incurred by a firm. Firms often analyze the effect of changes in any of the one or more of the above variables on the break-even output. The effect of the following 2 factors on the break-even output is often considered by the firms. First, changing the selling price of the product. We have seen in our numerical analysis of break-even output that if a firm raises the selling price of its product, the break-even output decreases. This can be graphically shown by a break-even chart, which we have done in image 1.4. It may be noted that hike in the selling price of the product would make the total revenue curve TR more steep. In image 1.4, TC curve portrays the change in the total cost as a firm expands its output. Note that it is only the total variable cost that changes. Fixed cost remains constant at OF. TR is a total revenue curve whose slope measures the price of the product. With TC and TR as total cost and total revenue curves respectively, OQB is a break-even output. When the selling of the price is raised, TR curves rotates to the new position TR dash. It will be seen from image 1.4 that this new total revenue curve TR intersects the given TC curve at the point E dash and determines OQ dash B as the break-even output, which is less than the previous break-even output OQB obtained before the hike in the price of the product. Thus, increase in selling price results in lowering of the break-even output. Second, substituting fixed cost for variable cost. Instead of raising the selling price per unit, the firm may consider to substitute fixed cost for variable cost in some of its operation. For example, when wage rates of labor rise, it has been found that many firms seek to reduce the variable labor cost through undertaking automation of same operation of its production process. Automation of some operations implies that the firm substitute fixed capital equipment for labor. As shall be shown below in the analysis of operating leverage, substitution of fixed capital for variable cost generally raises the break-even point. Operating leverage refers to the ratio of a firm's total fixed cost to the total variable cost. The greater the ratio of fixed costs to the variable costs, the more highly leveraged the firm is. The degree of operating leverage increases as a firm substitutes fixed capital, that is, and equipment for variable factors such as labor when the firm introduces automation of some of its operation. Extent to which a firm commits itself to high levels of fixed operating cost, which vary with time, such as insurance, rent, salaries, but not interest, as compared with the levels of variable cost. Firms with high operating leverage have high break-even points, but they show a greater increase in operating income with every increase in sales revenue in comparison with firms with low operating leverage. Also called operating gearing, it is one of the major components of operating risk. Limitations of linear break-even analysis, or what is also called linear cost volume profit analysis, should be noted. While linear break-even analysis is very useful and is often used by business firms to know their no profit, no loss level of output, and also to know the amount of losses or profits they would earn at different levels of output or sales. However, linear break-even analysis can be applied only in cases where the assumption of constant selling prices and constant average variable cost hold good. Further break-even analysis also assumes that a firm produces a single product or a constant mix of products. This does not represent a real-world situation where the firm often produces multiple products. When this is the case, or when even over time the product mix changes, it may be difficult to apportion the fixed cost among various products. However, despite these limitations, when properly used, break-even analysis can prove to be very useful in managerial decision making. So finally, we have learned today the chapter of break-even analysis. In this session, we have discussed meaning and concept of break-even analysis, methods of linear break-even analysis such as graphic and algebraic method. We have also discussed analysis of break-even point in case of nonlinear total revenue and cost curves. The script also includes discussion on the change, break-even, output operating leverages and limitations of break-even point. So that brings us to the end of today's last session on break-even analysis, and that finally ends the subject. Thank you very much for watching. Take care and goodbye.